Hello, my dear students. Welcome back to my YouTube channel. So today we are going to discuss lecture number 4 of electrostatic. So in this particular lecture, we will be discussing about Coulomb's law, its scalar and vector form with some great numericals. Hello, my dear students. Welcome back to my YouTube channel. So today we are going to discuss lecture number 4 of electrostatic. So in this particular lecture, we will be discussing hello, beta. Scalar and vector form with some great numericals. Welcome, salam, beta. So let's start now. Hassan, hello, beta. Hello. So I guess I'm audible and visible to all of you, right? Then let's start class. Thank you, beta. Thank you very much. Okay. So in last lectures, so we had discussed about charges and properties of charges, then charge density, the type of charge density, then methods of charging, friction, conduction, induction, then some numericals. So in this particular lecture, we will be starting about what conductors and non-conductors are. Then we will starting the most important topic from this particular chapter, that is Coulomb's law. Okay. If you have any doubt, you can just ask me, right? I'm just okay. So basically, we have two types of materials. In general, here now we are dealing with two types of materials, right? So one type of materials are known as conductors, and one type of materials are known as non-conductors. So conductors are those materials in which we will be having maximum number of free electrons. So conductors have maximum number of free electrons, or they have free electrons in a very abundant quantity. Okay. So due to this particular property, conductors allow electricity to pass through them. Okay. Just like if we talk about the example, we have the metallic spheres. Okay. Look, I have also written here, which allow electricity to pass through them. Property of a conductor. They have excess number of free electrons. Yeah, but I'm just we have started the lecture series in English, now. So that if we talk about the example, we have metallic spheres. Okay. So due to the abundance of a free electron, we know that charged particles show one property, that is repulsion or the attraction. Repulsion or attraction. Due to this repulsion, they try to be on the maximum distance. Let's suppose we have a sphere like this. Let's suppose we will take an example. Let's suppose we have a sphere like this. Look, this is my sphere. Okay, and I am giving a charge to the sphere. Let us suppose I am giving charge. I am giving charge to the sphere. Okay, so the charge will be on the outer surface only. So the charges on the conductor will be on the outer surface only. Why, sir? Just because of mutual repulsion between these, right? Because of mutual repulsion. Charged particle will show mutual repulsion, due to which they will try to be on the surface only. Okay, there is one more criteria, that is to maintain the minimum potential energy, right? That's one more criteria. But here we are talking about the mutual repulsion only. Why? Because we have only done this property. Urus gave me, beta, do one thing, just ping me a message in Telegram, There we can discuss these things. Okay, if you just go to the description part of this YouTube this lecture, now you will find my Telegram channel link, and just go there and just ping me a message, sir, which one is good, right? So we will have a discussion on that particular thing in my Telegram channel. Okay, so but if we talk about non-conductor, this particular property belongs to conductor. But if we talk about non-conductor, if we talk about non-conductor, if we talk about non-conductor, this conductor, so charge will be present throughout the volume. If this is my non-conductor, so my charge will be present throughout the volume, uniformly or non-uniformly. I guess we had the discussion on it, no? When we were discussing the charge distribution of multiple types of spheres, right? There we have hollow, we have shell. Hello, beta. Okay, so very common and good differentiation between conductors and non-conductors is like that. In conductor, we have a lot of free electrons present, but in non-conductors, we don't have any free electrons present. In conductors, electricity passes freely, but in non-conductors, there is a very restriction or the resistance to the flow of electricity. Okay, just like here, sir, charge distribution is throughout the volume. It could be uniformly or non-uniformly. If we talk about the example, we have non-conducting spheres. We have a non-conducting sphere, right? This was not so much important, right? Because we have discussed these things in our back classes in 9th and 10th. Now let us talk about the Coulomb's law. In my first lecture, we had discussion on charges. Then we discuss one property, like charges repel and unlike charges attract. So back then we had only discussion on, sir, repulsion and the attraction. But we don't deal with, sir, what should be the direction of the repulsion or the attraction, and what would be the magnitude of this repulsion and the attraction. Let us suppose I have a 4 Coulomb charge and I have a 2 Coulomb charge. What will be between these two? Now we will be having a repulsion. But if we have a 1 Coulomb and 1 Coulomb, there is also a repulsion. But what is the differentiation between these two? No, what is the difference between these two, sir? I guess in one example you have taken the big amount of charges. In second example, you have taken the smaller amount of charges. Due to the magnitude of this, now we will having a different magnitude of what? Force also. So Coulomb's law gave us a relation. Coulomb's law gave us a relation for what? To calculate electric force. To calculate electric force between charges. So Coulomb's law gives us a relation which relates what? Which gives the electric forces between charges. And Coulomb suggests that, let us suppose if we have two charges, one charge is Q1 and one more charge is Q2, and both charges are separated by the distance R. So there will be a force F. Force, what is F? Sir, F is force. And this force will be proportional to the multiplication of these two charges. And this force will be also inversely proportional to the square of distance between the charges. Coulomb gives a two statement that force which gets exerted between Q1 and Q2, it will be directly proportional to the magnitude multiplication of these two charges. Second point is, this force will be the inversely proportional, inversely square to what? The distance between these two charges. So let us combine these two equations. Let us combine now these two equations. Okay, look now. बहुत बढ़िया बेटा, है ना? चलिए, अच्छी बात है. तो अपना दुख दूर करने के लिए आप लेक्चर देखने के लिए आए हो। बहुत बहुत मेहनती हो फिर आप ना, बहुत फोकस्ड हो फिर आप पढ़ाई के लिए ना। चलिए, इतना दुख है आपको फिर भी आप लेक्चर देखने के लिए आए हो, बहुत बढ़िया बेटा। चलिए, now let us combine these two equations. Let us combine these two equations. So what we will get? We will get force is proportional to Q1. Force will be proportional to what, beta? I will write here, sir, this force will be proportional to Q1 Q2 upon R square. This is what? A Coulomb's law. So whenever in physics we have this sort of symbol, na, proportionality symbol. Okay, so whenever in physics we had this proportionality sign, okay, directly proportionality sign, so we have to replace it with equals to plus some constant also. So here, to get this one changed now, so what we have, so F is equals to K, we have K here, Q1 Q2 by R square. So this equation is what? It is Coulomb's law. What is this equation? This is what? Coulomb's law, where F is force. It could be force of attraction or repulsion. What is K? It is a constant. This one is a constant, okay, known as Coulomb's constant. This one is a constant known as Coulomb's constant. Okay. What is Q1? It is a charge. Charge on first particle. Charge on first particle. And what is Q2? So this would be charge on second particle. What is R? Distance between charges. Distance between charges. So if you have to write this thing in your examination, so you have to define like this, okay? You have to define like this. So what is F? What is K? Q1, Q2, and R. Done? Done now? Okay. Now let us explore many things now into it. So what do we have now? Look now. So what do we have now? We have an equation. What do we have now? We have an equation. Which equation? F is equals to K, Q1, Q2 by R square. This one is what is Coulomb's law. So we know now what Coulomb's law is. So Coulomb's law is a relation which gives you the magnitude of the forces exerted between the particles. If let us suppose we have the particle in air, let us suppose air or vacuum. We have two particles Q1 and Q2, and we are calculating the forces between these two particles in air or vacuum. So for that thing, we will define force in air or force in vacuum. I will write force in air or force in vacuum. Okay, let's suppose if we are taking these two particles and we are taking it into different medium. Let us suppose we are taking them inside a water, inside a kerosene. So that means we have a medium there, right? I will write force in medium. Force in medium. Sure, brother. Thank you. Thank you. If you can do this much for me, na? No, you can do it. You can do it. Okay, you can do it. Look, so we have a force in air or vacuum. So I need to write it K. So what is K? It is a constant, but it is basically close to 1 over 4 pi epsilon naught. For what? For air. So I will write 1 over 4 pi epsilon naught. Then Q1, Q2 by R square as it is. For medium, I have to write 1 over 4 pi epsilon only. Q1, Q2 by R square. So now look, 1 here, now look better. 1, we know what is 1. 1 is a constant, no? What is Q1? Q1 is magnitude, it is easy. We know what this thing is. Q2 we know. R we know. 4 is a constant, pi is a constant. But we don't know what is epsilon naught here. In the similar way, 1 we know, Q1 we know, Q2 we know, R we know, 4 we know, pi we know. But this epsilon, we don't know what it is. Okay? So basically, when, let's suppose we are walking somewhere, right? We are walking somewhere. So again, there will be a friction also when we are applying force on the ground. No? So there is a property known as friction. If we are talking about the water layers, there is a property known as what? Viscosity. Now here, if we're talking about the particles, one particle and one more particle, this particle is exerting some force in it, no? But here we have some medium. This medium will be giving some permission to this force to pass through it. And the permission is known as what? A permittivity. This permission is known as what? A permittivity. Yes, beta. Yes. No, Coulomb's law is only and only applicable for point charges. Okay, Coulomb law is only applicable for point charges. Dragon, yes, you can do it, no? That eventually you're just saying me now that you want to help me, right? You can do it. Look, beta. So here I have a particle Q1, here I have particle Q2. So this particle will exert some force on it now. So here what we have? We have a medium. So this medium will show some restriction, or it will show some resistance, or it will give some allow to your force to travel. This property of your medium is known as what? Permittivity. What is it? So it is permittivity. Permittivity. So permittivity is what? It is epsilon. It is what? Epsilon. So we have three types of permittivity. 1, 2, and 3. One is epsilon naught, one is epsilon, one is epsilon r, or we can write the k, small k. Epsilon naught is permittivity in vacuum, or permittivity of air, or it is a vacuum. Epsilon is what? Permittivity of medium, also known as absolute permittivity. What is it? What is happening with it now? It is what? Absolute permittivity. What is epsilon r? It is a relative permittivity. Relative permittivity. So what we have now? Sir, we have three types of permittivity. So we have what? We have permittivity of vacuum. It is a fixed value. Why? Because vacuum is only one now. But permittivity of medium, now we have different medium. For different medium, we have different permittivity. And relative permittivity means it relates. It relates permittivity of your medium to permittivity of free space. Okay. This one is having what? This one is having fixed value. It is fixed value. This one, it depends on medium, or depends on, yeah, it depends on medium, right? This one relates. The fixed value of epsilon naught, it is 8.8 10 to power minus 12. Permittivity of vacuum. This is variable now. For water we have different, for kerosene we have different, now for other material we have different. So what is epsilon r? It is permittivity of your medium with respect to permittivity of what? Permittivity of your air. So that means I can write permittivity of my medium would be equals to relative permittivity into permittivity of free space. Permittivity. Permittivity simple means permission given by your medium to force to travel through it. Simplest definition that you will get now. Permittivity means it is the permission given by your medium to force for what? To travel through this particular medium. So let us suppose we have particles, not two particles, and it is what? Inside water. So now this particle, one particle will exert some force on two particles. So look, the force is passing now. The force is passing through the medium now. So this medium will give permission to this force. This medium will give permission to the force. So this permission of your medium given to your force to pass through it, this particular permission is known as permittivity. Then it gives permission, na beta? So now we know, na sir, what is epsilon naught, what is epsilon r. So let's come back to our original equation. So this was my original equation, right? So now, sir, we know these things. What we know now? We know what is epsilon naught. So what is epsilon naught? It is a permission given by your vacuum, known as permittivity of air or vacuum. It has a fixed value. So what is epsilon? Sir, epsilon is permittivity of medium. So look beta, I will take this particular equation. Look now. So can I write now 4 in medium is equals to 1 over 4 pi epsilon. I guess we conclude one point here. Look here now. We conclude that we can write epsilon is equals to epsilon r epsilon naught. So let us take this particular equation and place here. In this place, let us put this value. Can I write here? It is epsilon naught epsilon r. The rest thing as it is q1 q2 by r square. Yes. Look now beta here. I will take these things now. I will just take these things. I guess these things are similar to this one, no? Yes. So I can write what I can write, sir. I can write force in medium. Force in medium is equal to force in air or vacuum divided by epsilon r. This is one more equation that we have to remember. The force in medium is equals to force in air or vacuum divided by epsilon r. Okay. Okay. So we know now each and everything of Coulomb's law. Let us go deep into it now. Let us go deep into it. Okay. How so? Look now. So particularly we know the equations now. Now we know these equations now. So I don't need to just give you some idea about these equations now. So let us talk about the units of it. Now, most important part, let us talk about the units of it. So what I can write here now, look, what is F? Sir, the F is, it is in force, right? Force in newtons. Force will be newtons, or in, if we talk about in CGS, so I can write what? Dyne, no? Force could be in newtons or dyne. And we know one more thing, it is Q1 or Q2. These could be coulombs. We can just measure the magnitude of charges in coulombs or stat coulombs or absolute coulombs. So I can write here what? Stat coulombs only. What is R? R is distance. So I can measure it in meters or centimeters or millimeters, micrometers, nanometers, angstroms, right? But what is K? Is there any unit of K also? Huh? Look, sir, F is equals to K Q1 Q2 by R square. What is F? It is Newton. K. Coulomb square by meter square. So therefore, unit of K would be Newton meter square per Coulomb square. Okay, this is what it is what? It is a unit of K. You have to remember the unit of K. Simple as it is. Okay, and if we are talking about the value of it, if I talk about its value, so K has two values. One is MKS or in SI, one is CGS for air or vacuum. In MKS value is 9 into 10 to the power 9. In CGS it is 1. In CGS it is 1. Do you know what is why there is a 1 value of it? Look, because K is equals to 1 over 4 pi epsilon naught. Done? So if I place the values 1 over 4, pi is 3.14, epsilon naught is 8.8 10 to the power minus 12. When you are placing these things now, so you will get a value this one. But in CGS, I have to place 1 over 4 pi. Epsilon naught is what? 1 over 4 pi. In CGS, cut out, so I will get 1. Look, this is my CGS. Unit for epsilon naught is 8 point. Now I will write epsilon naught also now. In MKS or in SI, one more in CGS. In MKS, it is 8.8 10 to the power minus 12. In CGS, it is what? 1 over 4 pi. These are the units of your epsilon naught also. Okay, done. Okay, now let us. So we have completed our Coulomb's law. Okay, we have completed our Coulomb's law. Now let us do some numericals for it. Okay, let's do some numericals. Okay, now we have some numerical on the screen. First numerical. Numerical is like two charged particles. Okay, so we have two charged particles. Done. And are placed at a distance of 10 centimeter. Are placed at a distance of 10 centimeter. This one, no? I guess in this class we will get something new, no, beta? Just like epsilon naught in CGS. Okay. So there are certain parameters that you will get new here. Okay, now here, so we have a numerical like two charged particles. Okay, we have two charged particles Q1 and Q2. Let's suppose, and these are placed at a distance 10 centimeters. So R is also given to us. What is the minimum possible magnitude? Okay, of the electric force acting on each other. So look how I will proceed to these types of numericals. First, you write your equation. Write your equation. I guess this one is my equation which gives a relation between charges. Now, it's Coulomb's law. Okay. Now look what things are given to us. We have two charges. Okay. Distance is given to us. It is 10 centimeter. If it is 10 centimeter, so can I write it equals to 10 into 10 to the power minus 2 meter? We know it, huh? We can easily write 1 centimeter. 1 centimeter is 10 to the power minus 2 meter. So 10 centimeter is 10 into 10 to the power minus 2 meter. Next part. What is the minimum possible magnitude of electric forces acting on each other? That means we have to find out what should be the minimum electric force. Look now, Q is given to us, R we know, so that means F depends on the magnitude of Q1 and Q2. So if F needs to be minimum, that indicates my charge should also be minimum. Minimum charges will be exerting minimum force. So do you know what minimum charge we have? You know what minimum charge we have? Yes, sir. The minimum possible charge is what? Electron. By property of what? Quantization. Charge will be in the form of Q equals to Ne. Quantization, na? Charge equals to Ne. So the minimum would be N equals to 1. So Q equals to charge of electron. That means my Q1 is equals to Q2. Both are equals to charge of electron 1.6 10 to the power minus 19 Coulomb. Place these values in my equation. So I will get F. What is K? K is 9 into 10 to the power 9. It is 1.6 10 to the power minus 19 Coulomb. Q2 is also 1.6 10 to the power minus 19 Coulomb. Whole divided by R. What is R? R is, I can write further, I can write it equals to 10 to the power minus 2, it is 10 to the power minus 1 only. So I can write here 10 to the power minus 1 square. So I will take these terms separately, 9, 1.6 and 1.6, right? So I will write here, sir, it would be 9 into 1.6 into 1.6. Then look here, bases are same, powers will be added. So what I can write here now, 10 to the power 9 minus 19 whole divided by 10 to the power minus 2. When I will take this upwards, it will become positive. It will become here what? Positive. So what is 9 into 1.6 into 1.6 is? Sir, it would be 2.3. So I can write, sir, it is 2.3 into, so 10 to the power minus 26 Newton. This will be my required answer of my numerical. So the catch here was we have to find minimum force. So, but minimum force for that we were not have given any specific value of charges. So we have to think for minimum electroforce we should have minimum charges also. This is how we can do it. And also what is permitted, can you explain the letter that is sufficient for ion picture? No, beta, these are not sufficient for it. Look now, for ion picture you have to do lot of numerical practices, no? So here we don't have that much of time now. I'm just taking some important numericals only, okay? Okay, so now next numerical. This numerical is a combination of 11th and 12th. Okay, this one is important, this one. Good one, huh? So I will write good one. This one is a good one. This numerical is a good one. So I will explain this one, no? A particle A. We have particle A, and this particle A is having some charge of this much. Okay, and also this particle is having mass of 10 gram, 100 grams, is placed at the bottom of an inclined plane. So we have what? An inclined plane from NLM, and the angle of inclination is 30 degree. Where should be my another particle be placed so that my particles should remain in equilibrium. My particles should remain in equilibrium. So let us make the diagram first, then we will just see what we can do, right? Look now. For my diagram, okay. So this one is my diagram. Okay. We have one particle at the bottom. Look, this is my one particle at the bottom. One more particle is somewhere at this particular point. Okay. Look now. This is particle A. Okay. This one is a particle B. This angle is given to me how much? It is 30 degree. Okay. Okay. No. 1 second. Particle B. Particle A mass this much. Okay. For this particular particle, my charge Q1, let's suppose Q1 is given to me 2 10 to power minus 6 Coulomb. And one more thing, that is mass. Mass is also given to me. Yes, mass 1. It is 100 gram, which is equals to 100 into 10 to power minus 3 kilogram. Okay. For B, with same charge, that means Q2 is also equals to Q1, and masses are same now, that M1 is equals to M2. Let us suppose distance between these two. Let us suppose distance between these two is R. So I need to find the value of this R. How to find it? Look, both charges are positive, so they will repel each other. So force on B would be like here. Now it is repulsion. This will be my force on it. If this particle should be in equilibrium, so there should be one more force. We should cancel the F's effect. There should be one more force which should cancel the effect of this force. So how we can do it? Look, we know one thing, that on this particular particle mass is there, so gravity will also be there, no? Okay, so look, this would be my mg. It is theta. It will be my mg cos theta, and this would be my mg sin theta. Mg sin theta. If for this particle to be rest, this force should be equal to this force, then only it will be in equilibrium. So what I can write here, I should write here that force F, which is Coulomb's force, it should be equal to mg sin theta. What is Coulomb's force? It is K Q1 Q2 whole divided by R square. Mass, what is mass? Mass is 100 10 to power minus 3. G's value is 10. Then we have sine 30 degree. What is K? K is 9 into 10 to power 9. Q1 is equals to how much? 2 into 10 to power minus 6. Q2 is also 2 into 10 to power minus 6. I need to get the value of R only. So look here. 1 2 3 0 1 2 3 0, it will cancel this 0, no? So we have only sine 30. Sine 30 is how much? It is 1 by 2. So I will take 2 here. So it will be equals to 9 into 2 into 2 into 2. 10 to power 9 minus 6 is equals to R square. Look, 2 2s are 4, 4 2s are 8, 8 into 9. So I can write here, it is 72. So it will be 72 into 10 power 9 minus 12 equals to R square. Done. It would be 72 10 to power 9 minus 12. It is minus 3 equals to R square. I can write like this, no? So therefore, I can write, sir, my R came out to be under root of 72 10 to power minus 3 meter. So this is how we can proceed in these types of numericals. Okay, these numericals you won't get easily in your classes also. No, this is a very good numerical, very good numerical. Okay, that's why I have tagged it in a very good numerical. You can practice more numericals like this. No, if you want to make it somehow what tougher, then let us suppose this wedge is moving with velocity something, right? Okay, okay, so this is how you can do these types of numericals. Okay, it is not like you will do only numericals if f is something like that, okay, and k is something like that, q1 q2, and you have to find r. No, that is a simple numerical. But as you have seen the NEET paper, no, this year, that means you have to do some sort of good type of numericals as well. This was a good one. Previously in my class of I guess in second class, we discussed a numerical on mole concept also. In physics, we discussed a numerical from mole concept. But you will tell me, sir, why we are discussing a numerical from mole concept in physics? But if you have studied your NCERT physics, right, you will find in page number 3 or 4, so you will find a numerical there in based on mole concept. The numerical, na, how many electrons would be there in a 1 cup of water? You can simply do the 1 cup of water type of numerical with a mole concept. Okay, that means you need to be very good in relating your subjects, chemistry, physics. Okay, later on in 11th, now you have done some sort of pump problem related to heart, not the biology one also. Okay, now let's do some easy numerical also. Okay, so what we have here, okay, if you have some doubts, you can ask me now. Look now, numerical is if we have two identical particles. Identical means same. Identical term means same. If we have same particles, and if the net force is zero, net means at the end. Let us suppose I am giving you 2 rupees. Then in second minute I gave you 5 rupees. So what is the net amount you will have in your hand? Sir, 2 plus 5, 7 rupees. So 7 is a net. 7 is what? Net. In the same way here, we need the net force is 0. So find specific charge. Do you know what is specific charge? What is specific charge? You have done the specific charge in your chemistry also, no? Specific charge is the ratio of Q by M. A ratio of Q by M. So look now. Here particle's mass is M, charge is Q. Here particle mass is M, charge is Q. Okay. We know that if we have two masses in between masses, there will be a attraction. Newton's law of gravitation. So this one, one will attract the second one. So there will be what? Force due to gravity. Look, we have same charges. So there will be what? A repulsion. This will be force due to Coulomb. So how many forces we have? Sir, we have two forces. We have Fg and we have Fc. So I will write, sir, gravitational force should be equal to Coulomb's force. Then only in this particular condition, the F net would be 0. In this particular condition, my F net would be 0. What is gravitational force? Sir, it is G M1 M2 by R square. Sir, what is Coulomb's force? It is K Q1 Q2 by R square. R square cancel out. So G, what is M? Sir, M is M. M2 is also M. K is K. Q1 is Q. Q2 is Q. I will write G M square is equal to K Q square. So I can write here it is G by K is equal to Q square by M square, or I can write Q by M whole square is equal to G by K. I will take square here, there it will become square root. So Q by M will be equal to under root of G by M. This is how we can do these numericals. So no, G by K, so G by K, it is G by K. G by K. G by K. Okay. Okay, now next numerical. Okay. Do you know why? Do you know what? I will just ask you one question. Why Coulomb's law is only and only applicable to point charges? Why? Do you know the reason behind it? Why Coulomb's law is also applicable to the point charges only? Okay. Look now. To give the answer for this particular doubt, now I have taken a numerical here. I have taken a numerical here. Okay. So the numerical is like, let's suppose we have two spheres. These are what? These are spheres. These are not point charge. These are spheres. Okay. Spheres with charge Q1 and with charge Q2. So we have a sphere with charge Q1 with charge Q2. And the separation of center between these two spheres is R. It is what? R. So how to write Coulomb's law? So let's suppose we don't know anything now. So I can write Coulomb's law like this now. So why, sir? Because Coulomb law is equals to K magnitude multiplication divided by the distance square. So it is good now. It is K Q1 Q2 by R square. Look now. We can use this formula if and only uniformly distribution is there. Uniformly distribution. For a uniform distribution, we can assume charge beyond center. Charge at center. Okay. But look here now. It is not compulsory, beta. Look. I will give reason why it is not applicable to these things now. Practically, now, ideally you can do it. In ideal case, you can do it now. Ideally, you can qualify NEET now. But practically is different thing now. Look. Here. Look now. One sphere. One more sphere. If we have given a charge of plus here. If we are given a charge of plus here, right? And we have given a charge plus here. Okay. So yeah, in this particular case, we can use it is R Q1 Q2. Yes, definitely. It is my guarantee. You can write F equals to K Q1 Q2 by R square. But you know one thing, na, the positive will repel positive. One thing that you know, the positive will repel positive. So what actually will be there now? What actually will be there now? Look. Actually, the thing will be, look. Yeah. This positive now, these positive and these positive will repel each other because these are on the face side now. They will have minimum distance between these two, so they will oppose each other. So this will apply some force. This positive will apply some force on this one like this. This will apply some force like this, due to which the whole charge will get accumulated in this way. Whole charge will get accumulated here only. Okay. So look, if 4 charges get us accumulate here, and look, distance is effective now. Why? Because this distance is not same to this one now. This is not same of this one only. This is not same as this one, the previous one. It gets changed now, no? Why? Because due to repulsion, no? It gets changed. So my R effective is more than R. If my R effective is more than R, so therefore I will write my F that we calculated this force, no? This one, it will be less than K Q1 Q2 by R square. That means my calculated value, the value that I am calculating, this will be less than the actual one. This is actual, no? This is ideal case, but this is ideal case. And this one is what? This one is practical case. This is what? A practical case. A practical case. That's why we are not using Coulomb's law in spheres. Okay? You will get this sort of question from your NCERT. If you can open your NCERT, no? There is a line written now. Why Coulomb's law is not applicable to the big spheres. Due to this particular condition, we are not actually getting the information of it. Now, look, my value, if I just calculate the value, it would be equal to K Q1 Q2 by R square. But in a reality, no, in a reality, my force will be less than this one. Why? Because the separation increases. If separation increases, eventually my force will decrease. Look here, no, it is written here. Now, in this case, if I need to write ideal case, what you will write? Sir, F will be equal to K Q1 Q2 by R square. Ideal case. But what actually will be there? Now look, here will be positive. We know here. Here will be negative. And this positive will attract this negative. This positive attract this negative. So what will happen? What will happen? The R effective will decrease. R effective will decrease. It will come closer to now due to the attraction between positive and negative on the surfaces of the sphere. It will come close. If R effective decreases, F increases. So my F nu will be more than K Q1 Q2 by R square. Okay? You have to think like this, now. You need to think like this. Okay, now next one. So if we have this one now, in ideal case, my charge will be uniformly distributed throughout the surface, but in reality, now it will get what? Repulsion. So these charges will get accumulated backwards. So there, what will happen here? Sir, R effective increases. So F will be less than the K Q1 Q2 by R square. Got it? If you have any doubt, you can ask me in the comment box. There is no issue. Easy, no? Super easy. But you need to just study very hard now. You need to study from the basics. Look, this one is a basic now. But I know a lot of students didn't know it, this one also. They will then know this numerical won't get asked, that NDA will not ask this one now. But this is basic now. You need to study from the basic. This one is included in NCERT. It is not like you will get K, Q1, Q2 by R square, the numerical only on those things. Right? You will get some numerical aspect on this one also. What will happen if something will be there now, like this one? You should be in the position to just manipulate the numerical. Okay? Now, next numerical. If let us suppose I have two particles. If let us suppose I have two particles. Okay. Now I am taking these two particles in air or vacuum, and distance between them is r. I am not changing the r. My distance is r only. Okay. And my force between these two particles in F air. Now, if I just put these two particles inside some medium, I have to take the charges as it is Q1, Q2. So, what should be the distance between these two particles? So the force exerted in air should be equal to force exerted in medium. How we can do it? Look with how we can manipulate it. Look, what is force in air? So I can write, sir, it is 1 over 4 pi epsilon naught Q1 Q2 by R square. Okay. Medium, it is 1 over 4 pi epsilon naught epsilon R Q1 Q2 by R. We can, let us suppose I can write R dash square. R dash square means distance in medium. Is what? Distance in medium. Now look, 1144 pi epsilon naught Q1 Q2 cancel out. Then what I have, right? I have 1 over R square is equals to 1 over epsilon R 1 divided by R dash square. Done? So what I can write here, sir, distance in air square will be equals to epsilon R distance in medium square. Okay. This equation, if I further classify it, so my distance in medium is equals to distance in air square divided by epsilon R, or distance in medium, it should be equals to distance in air divided by under root of epsilon R. This relation you need to remember. Okay, this particular equation you need to remember. So let us do a numerical on the same one. Okay, numerical on the same one. Look here. If the distance is given to me, it is 4 centimeter, and epsilon R is 9. What is distance in air? So we know that distance in air is equals to under root of epsilon R distance in medium. We know this one now. Distance in air, I need to calculate this one. Under root of it is 9, and distance in medium, it is how much? It is 4. So it will be 3 square root, then 4, it is cancelled out. So distance in air equals to 3 into 4. 4 3 is 12 centimeter. 12 centimeter. Medical student, hello beta. That means if we have two particles with charge Q1 and charge Q2, and we have placed them inside a medium, distance between them is 4 centimeter and epsilon R is 9. Now, if I have to get same forces in air also, I need to increase the distance by 12 centimeter. Now here, last topic of today's class. Look, Coulomb's law is due to the mutual interaction. Mutual interaction means one particle will act force on second particle and second particle will be applying for the first particle. No? Just like Newton's law. And if it obeys action pair, reaction pair, that means here if we have a charge q1, here charge q2, both are separated by distance r. Now force on this one would be equals to force on this one equals to sir k q1 q2 by r square. If both are positive, it will be repulsive. Same here, it will be repulsive, but magnitude of forces will be the same. Right? Look, equal and opposite action pair, reaction pair. Okay, forces along the line joining the charges. That means we have 2 points. So we have these two centers. Now join these centers. Okay, my force will act along these centers only. This can be either repulsive or attractive, but it should be only along the line joining the charges, not affected by the presence of other medium. Remember, that means suppose for this one, let us suppose, look now. Look now. Charge Q1, Q2, and Q3. Q1 will just, let us suppose, will push it. Suppose we'll push it. So force will be K Q1 Q2 by R square. So this, let us suppose this particle is not there now. So my force will be like this. If I just place one more particle here, Q3, this Q3 won't affect this one. This will be same as it is. Okay. Yeah, net force will change on this one now. But the exertion of force due to 1 on 2, this will be same throughout. Either if there are multiple charges present now. So it won't affect this one, the original one. It is what? It won't get affected by the presence of the third charge. Meaning of this one. Okay. Now we have a Coulomb, we have a vector form of it now. Last topic, then we can wrap up this session. Vector form means that force is a vector quantity. That means now how to represent Coulomb's force also. Now look, Coulomb's force is also force. So it is also a vector quantity. Now how to represent Coulomb's law in a vector form? Look now. So let us suppose we have a coordinate system. Here I have charge Q1. My charge is Q2. For Q1, my position vector is R1. For Q2, my position vector is R2. Look, I will join the center of these two. Why? Because force will be along this line only. Both are positive, suppose now, and the distance is R only. Let us suppose R only. Look, if you have to write Coulomb's law in scalar form, if you need to write Coulomb's law in scalar form, so you can write F equals to K Q1 Q2 by R square. Scalar form. If you need to change this one into a vector form, what you need to be done here, I will take a vector on F. In second side, I have to write R cap. This one is what? Magnitude. This one shows magnitude. And this one shows direction. That's why we are taking this one. And one more thing, R cap is equals to R vector divided by R magnitude. This is R cap only. This is R cap only. How we can do it now? Look, force on this charge, this one, Q1 will push this one now, and it will push it like this. So I will write force on second particle due to first. So how I will write here? Force on particle first due to particle second. In the same way, look, in the same way, what I can write here, in the same way, this will also push it, no? To also push it like this, I will write force on 1 due to 2. What is this one? Force on particle first due to particle second. No. Force on 2. No, here force on particle 2 due to particle first. Okay. Force on particle second due to particle first. Or particle first. Yeah, this is correct now. Okay. Now there will be a one sort of confusion, no? And that would be if you are going in this way. So you have to write you are going from 1 to 2. You are going from 1 to 2. Okay. Look here. This is my R1. This is my R12. This is my R2. We know from 11th. We know for 11th vectors. How we need to add vectors? On the head of first vector, there should be tail of second vector. And resultant vector is between the tail of first vector to head of second vector. So according to the law, R1 vector plus R12 vector. One second. Yes. R1 plus R12. That is R12, no? Yeah, R12 equals to R2. So R12 is equals to R2 minus R1. This one. Okay. Look, I can write, sir, F is equals to K Q1 Q2 by R square R cap. It would be R vector by R. So, sir, what is R vector now? Look, I can write K Q1 Q2 by R square. R vector would be this one. It will be R12 cap. It is F21, no? F21. Divided by R21 mod. So look, the magnitude would be R only, no? Yes. So I can write it will become to K Q1 Q2 by R cube. This R and this R, no? R cube. Then I will have R12. Or I can write K Q1 Q2 by R cube. In place of R12, I will write R2 minus R1. This is how we can write Coulomb law in a vector form. In the same way, how to write F12? Sir, F12 would be K Q1 Q2 by R cube. It will be equals to R1 minus R2. R1 minus R2. Okay? You have to remember these formulas. And one more thing that you need to remember, whenever you are applying Coulomb's law in vector form, put charges with sign. It is a compulsory charges with sign. Okay. Look, in the back numericals, we are not taking the sign of Q1 and Q2, na. But if you are dealing with a vector form of Coulomb's law, you have to do na. Positive and negative sign, you have to put it. Look, how we can do this numerical. If charge of first particle is 1 microcoulomb, charge of second particle is 10 microcoulomb, radius is 10 centimeter. What is F12 by F21? Sir, we know that these are action-reaction pairs. So this will be 1 only, right? So can I write it? F12 divided by F21. I will write it. No, there is no issue. Look, I can write K Q1. Q1 Q2 by R square. Whole divided by same. K Q1 Q2 by R square. Both will cancel out. No? My answer will be 1:1. said NEET PYQ. Okay, you will find this numerical in a lot of modules also. So this numerical also. Okay, this one is good numerical. So we have a charge Q. How to separate these two charge particles so that the force between them would be maximum. How we can do it? So for this particular sort of numericals, let us do one thing. Let us take one charge as a minus Q and one charge would be Q minus Q. So what will be the force between these two? So I can write F would be equals to K, Q1, Q2. Q2 will be like this divided by R square. If it is R square. So I will get F equals to K, QQ minus Q square divided by R square. Look, K constant, Q constant, R constant. So we are changing Q. So can I differentiate dF by dQ? So K is constant, R square is constant. I will take it outside. Now I can do the differentiation of what? Q minus Q square only. Look now. So what I will get, I can write dF by dQ is equals to K by R square. Differentiation of KQ would be only Q and 2Q is 2Q only. If you want to find maxima, so this should be equal to 0. So 0 equals to K by R square Q minus 2Q. So I can take here, it will become 0, this will become 0. So my Q minus 2Q equals to 0. So Q equals to 2Q. So Q will be equals to Q by 2. So that means if I have a charge Q, so if I just divide it into half of, I will get maximum force between these two. If you don't know how to do this one, na beta, this one, na, you can go to the one short lecture series playlist of mine na, on this channel and just watch basic mathematics. There you will get these things. Okay. Okay. Let us do second last numerical from NEET also. Yeah, it is not a numerical. So it is a short trick how to get it. Look, K we can get it, Q is easy. How to write R? Every time you need to write R as it is. R target minus R source. So what is the meaning of it? Let us suppose it is one charge is second one, distance is R, force F. This is force on 2 due to 1, force on 1 due to 2. That means 2 is target, 1 is source. How to write R? It is simple. R target minus R source. Simplest trick. R target minus R source. Sir, how I can write this thing now? In numericals? I will show you numerical now. Look. First we will do a NEET PYQ, then I will show you how to apply the formula target minus source. We have a hydrogen atom, okay, with proton, electron only. So we know that charge on proton is plus E, charge on electron is minus E. So I can write, sir, F would be equals to K, Q1. Q1 is plus E, Q2 is minus E. If distance is R, so I can write it R square, then R cap. Okay, it is minus K E square by R square, R cap. NEET PYQ, no? Easy? It's very easy, right? You can do it. Okay, let's do one more last numerical, then we can just wrap up the session. Okay, look here. If my charge Q1 is equal to 4 Coulomb, sorry, 4 Q, and my Q2 is minus Q, and coordinates of first one is given, coordinate of second one is given, I have to find charge on Q1. Charge on Q1. So what is Q1? Sir, find force on Q1. So Q1 is a target. So I guess which indicators Q2 will be source now? That means Q2 is applying charge on Q1. Okay, so I will write formula now. Look, in vectors. So in vectors, I can write F K Q1 Q2 by R cube, then R target minus R source. Easy, right? Okay. So what is, I can write this one. Now look, this one. Is it 4I cap plus 5J cap plus 1K cap? Is it I cap plus J cap plus K cap? So this one is target. This one is source. So I will write here K 9 10 to the power 9 Q1 plus 4Q Q2 minus Q. It is RQ. R target is 4I cap plus 5J cap plus 1K cap minus I cap. This minus into minus is minus into J cap minus K cap. 4I minus 1I, that is 3I only, plus 5 minus 1, that is 4J. 1 cancel out. It will be 9 10 to the power 9. It will be 4 minus Q square whole divided by R cube. This one. How to find R cube now? If my R is given Ri cap plus Rj cap, like this now, or X or Y, so it is mod is equals to X square plus Y square root. So here I can write it is magnitude is equals to 3 square plus 4 square root 9 plus 16 25 5. So my F came out to be minus 9 fours are 36. Then we have 10 to the power 9. We have Q square whole divided by 5 cube minus 36 10 to the power 9 Q square 5 for 25, it is 125. So this is my answer. This is how we have to manipulate our questions and we can get our answer. Okay. So I guess, okay, in this particular class, we had complete from 0% to 100%. You can now read your NCERT also, right? You can just do DPPs from your institutions. You can do module now. You can do the NCERT also, okay? In two topics. One topic is Coulomb's law and second is a vector form. So in next class, we will be starting superposition principle, okay? So we have topic superposition principle. Then we have a topic equilibrium, how to find the equilibrium, okay? And if you have any doubts, now after watching this lecture, if you find any doubt in the class or in your concepts, you will find my Telegram link in the description part. You can enter into my Telegram. There you will find my username. You can just send me a message privately, sir. I have the issue like these things, right? I am teach. If आपको electrostatic tough लग रहा है, that's why मैं आपको समझा रहा हूँ ना आपको. If you are preparing for boards, it is very easy. But now, from 2025, if you are preparing for NEET now or JEE, so you have to do some sort of level up now. I guess in this class, I have shown you the simple numericals, but good numericals. These are not the जो पिछले जो पढ़ाते हैं ना 4-5 वो numerical नहीं है. You will find a different numerical here with good concept things, right? Look here. You will find here how we can use in this particular numerical, how we can use Coulomb's law. Backwards, you will find in hydrogen one, or you will find the short trick. How we can put the basic mathematics here. You can find it. Or if you go back, you will find, okay, this one also, good one. And why there is some sort of assumption, this sort of exception in Coulomb's law, why it is only applicable to point charges only, right? Then we have the specific charge. Then we have this one very good numerical. If you get back and back and back now, you will find these good numericals. Okay, this was from IIT, and I guess you will find this numerical in NEET also. How we can get it now? A lot of student doesn't know how this came. How this came. We are having this thing now. How charge distribution takes place between the slabs. Okay, and you will when you will be doing your electrostatic now, you will find one thing. Why? When you will be doing the capacitor part. So whole charge is here now. We are not writing any charge here. Okay, why? What is the reason? Okay, you don't know. You are saying yes, sir. Yes, yes, it happens now. But what is the reason behind it now? I have shown the reason upwards. So you have to just learn from the basics. And if you find something, if you are not knowing something, now just follow my lecture series blindly. You will get everything in my class. You will get your NCRT clear. You will get your module. I have not seen your coaching module. You will get your module done here. You will get your DPPs, the most tough numerical from DPPs here. No, you will get those things done here. You will get NCRT, everything. Okay, but the only thing is you have to watch these lecture series from basic now, from first one. It is not like you will start only by watching fourth lecture or fifth lecture. No, go with the basic one. Start from the first lecture, then second and third and fourth. If you find some difficulty in doing some mathematical calculation, go to 11th class, study basic maths, vectors and UND. Those are basics in whole physics. Okay, you can just reach out to me now in my Telegram group that we can discuss. Okay. Okay, I guess I need to now stop my class. If you have anything in 1 minute, you can just ask me. If not, then I will just end up my class. Thank you, Beta. Thank you very much and good night. And daily, now I will try to come online daily for a 1 hour session daily. Okay. Okay. Thank you, Beta. Bye.